quickly. I'm just going to kick off the build. I will not be demoing 256 nodes today. I apologize. And there is an asterisk there as well, because I didn't actually end up getting 256, but I got close. I am doing a 2-node cluster build, so very quickly, I'm just going to hit a Terraform apply. I'll explain what that means in a second. And may the demo gods bless me today. I don't know if it works. The screen is going to be populated stuff. It's not particularly readable at the moment, but it will say what it is going to go and create. I have cheated slightly. I wasn't sure how the public Wi-Fi was going to go, and I wasn't going to try and upload a 2 GB ISO live, so I have done that preparatory. So the plan here is saying it's going to add 23 resources to my Azure tenant. I'll go into detail of what those are. I'm just going to hit yes, and then it will start, and we'll come back to it later. And hopefully it hasn't exploded while I'm presenting. Right, it's going. Cool. All right, go on to presentation. So who am I? For those who don't know me, my name is Bainsfair. I've been working with VMS for 2 years, so not a long time at all for most people. I'm a VMS ambassador. Not only do I not have a digital number, I actually don't think I was born while digital was still around, so I apologize, I remember that. And I started my career sort of working in the Azure 365 space, and sort of by happenstance stumbled upon VMS. I will add a quick disclaimer that everything that I'm doing is just my own pet project, proof of concept type stuff. I'm not running anything in production. In fact, I'm not running anything on the VMS nodes at all. There's no programs, nothing. It's just building a VMS node. So I have no idea how it actually performs. So if you do become inspired by this very inspiring presentation, then use at your own risk. And I will thank Raphael, Cody, and this gentleman here as well, probably as well, because they're doing stuff alongside what I was doing. And I don't know if any of my stuff helped them, but their stuff has most certainly helped me. There was a lot of trial and error, and a lot of tearing my hair out at 2 a.m. wondering why things weren't working. There was some sage wisdom in 2 key areas which helped push what I was doing along. I may have got there by myself in the end, but they saved me probably weeks. For those who don't know, I've put a description up there of what Terraform infrastructure as code is, but basically it is as it sounds. It's you write code on your local machine, you connect it up to your cloud instance. It is a cloud agnostic tool, so while the code isn't exactly the same, you can use Terraform with public clouds, private clouds. I think you can actually connect it up to local VMware. I haven't tried that, but you can. You will have to do some rewriting, changing between clouds, but Terraform is a cloud agnostic tool. How does it work? You write code in a language called HCL. It's a declarative language. There's a screenshot there that doesn't scale very well. That's why I'd be using LibreOffice. But that's a screenshot of, I think that's actually creating a virtual machine, or the output of creating a virtual machine. So yeah, you write your HCL, you connect it to your cloud environment, you run Terraform, which is exactly what I did just at the start of this presentation, and you watch it go and create resources. While you use Terraform, basically the benefits of writing code but translated to infrastructure, you get your version control, automation. You can reproduce it. In my case, you can run stuff in for each loop. So yeah, you can instead of creating one thing, you create X number of things. And yeah, you can theoretically connect it to any cloud. It's not like you can just grab the same code and point it to a different cloud provider and it'll just work. You do need to change the names of everything. Fortunately, every cloud provider has different ways of doing things. They call things different things. You need different pieces of infrastructure for it to work, but theoretically, you could move it between different cloud providers. So I think I was talking to Brett actually in October, where I kind of had this idea formulating in my head as I'm walking along a Boston street, where you know, I know VMS a little, I know Cloud also a little, and I know Terraform also a little, but I think you know, using Terraform, I can basically build VMS instances in the cloud. So let's give it a go for fun. So I made a couple of choices, which you know, had differing results with, but these are the choices that I made. The reason why I chose Azure is because that's where I started my career. I know Azure better than any other cloud. I just kind of hoped that it would work and actually have the best results in Azure. I did end up trying on Azure, AWS, GCP, and Oracle Cloud. Funny enough, I think the best results that I had on was Azure and then Oracle Cloud, which I tried last. AWS and GCP, I had mixed results. I think that was kind of just by chance. I just chose 2 vCPUs and 8 gig of memory, just to give me plenty of headroom. And I went with Oracle Linux just as I picked a random Red Hat variant, kind of didn't really matter which one. I had a few problems running onto. I'm sure it would work. I had problems, and instead of debugging them, I was like, to switch to Red Hat. I wasn't particularly fussed. How's it going to look? This is actually a diagram that was automatically built for me by uploading my Terraform config to a site called Brainboard. I have no idea if they're using AI or something in the background. I just thought it was cool, and I wasn't particularly bothered by losing any data there. But I had to move some of the boxes around to make it more user readable, but it generated all that for me. That was zero config. Upload the code, generates a network diagram. Pretty cool stuff. This was not generated automatically. This is generated by me when I realized that I didn't actually include any of how the actual nested VM works. But if you attended any of the other cloud webinars or the talks here, then it looks the same thing. You've got 2 NICs with MAC tag pass through NIC to the OpenVMS host. There's 2 subnets. One of them is a subnet for the host, one of them is a subnet for the VM. Only one public IP. I didn't really think of adding a public IP to the VMS host. I don't know why, I just forgot about it. I was happy enough with this merge console into the VMS node, and that worked fine. So yeah, I got started on it. You do need to write some foundational pieces whenever you're working in the cloud. So up on screen, there's the code for the resource group, which is kind of a logical container for everything in this project. The different cloud providers do things differently. I don't know if all cloud providers have this concept of a resource group. I think Oracle does it. Building the networking information. So you build a virtual network and then you build sub networks within that network, and then you set up your public IP address config for the hosts. So you can see there's a lot of Terraform kind of, the way that you're kind of supposed to write it is by referencing things you've already written and not writing things down twice. So instead of writing the location of where you want things over and over again, you write a variable for the location, then you call that variable, and then instead of calling that variable, you call another resource in your code to then refer to that. Instead of rewriting the same thing over and over again, change it once, applies everywhere. Yes, so then there's how do we get the VMS onto this host? The first part is the storage blob. So within the Terraform code, there is code for storage blob. Storage blob is just I don't know what the other equivalents are, like E3 block storage in Oracle Cloud, just logical container for files. Inside that storage blob, there'll be the VMS ISO, there'll be a setup script, which I need to call, and the way that I was setting up VMs was by a predefined XML. So when you're creating virtual machines, you can either do it by going and using the Verge console to create the VMs, or you can have an XML and then define a VM from that XML. So that's the way that I did it. Two ways to skin it. I don't think there's a wrong or right way. Although the way that I was doing it did introduce a problem, which was one of the ones that Raphael helped me with the MAC addresses. But I think I have a slide on that. If not, I'll touch on it. But yeah, so that's one of the things in that. Storage container is a really long bash script, which I'll go into more detail later. But there's a screenshot at the top there, which is Azure's way of running scripts in post. So once the VM is built, how do we run the script to then get started on this build? Other cloud providers do it differently. Most cloud providers use something called Cloud Init. Azure doesn't seemingly. They actually have to call a custom script extension to then get the script to run. But the app is the same. It runs the script once the VM is built. Yeah, so how does the script actually work? So the script I've kind of broken up into two bits. The first bit is pretty easy. Downloading prerequisites for virtualization to run, plus a couple of other things that might be handy, like the libvirt GUI. So it runs the graphical representation of Verge. Need to download something like ascopy, because ascopy is how we get files from the storage blob to the VM. So that's doing preparations. There's also a bunch of variable declarations, one of which is to get the MAC address of the Ethernet adapter, which is one of the problems that I had. And then also creates the VM using the XML, using the version define command. And then the next bit is basically how we're going to build VMS. So if I'm building VMS from scratch every time, I need to go through the installation process. To do that on KVM, the serial device is a file. So you can use echo to echo lines to the serial file. That $SRL is the variable that I have for the serial device file, /dev/bts/0 usually. And then you do that a lot, and you'll get a built VMS node at the end. I don't know how many times I had to build this. The main problems I had with building was because this method relies on timely responses in terms of I/O. Basically what can happen is about halfway through the script, if the line didn't get through to the host in time, then the whole script's out of whack. It's very reliant on things answering in a certain manner. The way that the guys at VSI are doing this is better because it doesn't have this problem expect. Runs way more cleaner than that. Again, two ways to skin it. But thankfully, Azure Spot makes this incredibly cheap. Azure Spot is, there are other, again, cloud providers called different things, but it's a concept where you are running on spare compute within Azure's data center. So it's a absolute fraction of the price, but it can be deallocated at any time. So it would be something that you could run a permanent load on, but because I'm trying to build things over and over again, it doesn't really matter to me. And if in a scenario where you were, you had a VMS machine built in a pipeline to run something and then destroyed, you wouldn't care because it would be, you would destroy it before Azure would destroy it. I save money, especially for me, because it's only in my own pocket. So after building a node, what do we do now? So I don't know who's done the system manager courses. That's a quote from Dahlia before she was CEO. I did not go and fact check that quote. I have no idea if 151 nodes is the largest node cluster. It was a number to aim for, and NetBox doesn't allow more than 96 VMS cluster nodes. So we go big, basically. So yeah, how do we get to 256 nodes? I mentioned before that Terraform has a for each concept. So the way that I set this up is not very smart, but you could do it better. But the idea was that there would be a variable map, and you would map sort of X to Y. And I thought originally that I would need to do manual IP addressing, which isn't true because Azure does DHCP on all mix. But in a scenario that you don't have DHCP, you will set up name equals blah, IP equals blah, etc. So I ended up just having one-to-one, so I could have done that in a different way, but that's just the result of how I ended up. But it's a similar thing. You got a for each, and then you however many entries I have in this map is how many nodes built. So right now that's what's building right now is VMS CH1, VMS CH2. We built with a cluster, so 2 cluster nodes, pretty like, I don't think I had any problems with 2 cluster nodes. But then going beyond that, I started to run into problems with my Azure account. By default, you only get 10 vCPUs, and I think you get like 20 public IP addresses, which is still quite a lot. Asking for 550 vCPUs was actually fairly instantaneous. They didn't have a problem with that. My request for 270 public IP addresses did raise some eyebrows. I did have to answer a few questions on why I needed 270 public IP addresses. And it's also quite expensive to run 270 public IP addresses. You didn't really need that many public IP addresses. I probably could have gotten away with not doing that. But that's the way I've been doing it with 2 nodes. And then at that point, it was kind of funny to ask for 270 public IP addresses. So I was kind of happy to keep going along that direction. But they did humor me after some explanation of what I was doing. I don't think they knew what VMS was, so that's okay. So then this is after I set the node amount to 256. So that screenshot there is telling me it's going to create 1,807 objects in the cloud. Most of those will either be the nodes, the scripts, the public IP addresses. Yeah, so it adds up quite quickly. And at this point too, Terraform will only build 10 resources at a time unless you specify otherwise. And I figured that would take whatever, 25 times 45 minutes. That will take a long time. So you do have to specify a parameter called parallelism to set that to 256. So they all try and build at once. Surprisingly, you don't get rate limited at 256 nodes. So I didn't try 256 nodes on cloud providers. Your mileage may vary on trying to create that many nodes. I don't know why you'd be doing that anyway, but I knew that would happen. Cool. So this is a video. It's supposed to be a video of the cluster nodes building. So we can come over here. Oh, it's still building. Wow, cool. The good thing that I kept the recordings. If I could minimize this. No, it's not relevant to minimize. I'll go back to the videos later of the cluster node building. I can't pretend. I kept the original screen recordings. And also there's 2 recordings because it was 2 o'clock in the morning when I was building these, and I forgot to set my terminal width and height beyond 80 by 24, which doesn't show that many nodes. It should like 10, so I had to restart the recording with an adjusted number. So the final number we got to was 239 cluster nodes successfully built. I gave them about 45 minutes on top of the scripts running to actually join the cluster. And I also couldn't get a full render beyond about 200 nodes or so, and the screen starts doing some funny things, and I couldn't get that to work, and I just did a show cluster conf write and then pull the file out, and that's an extract from the file that I pulled out. So yeah, 239 nodes. Technically going into cluster. Then we start to run into problems, which again, I don't really want to run this again just trying to troubleshoot because it's very expensive to run. But that screenshot goes the logic I had for adding 512 unicast routes, because it could technically be anything in the /23 subnet. So just to be safe, I just put all of the potential IP addresses in there. And things start happening that I can't really quantify beyond what I saw. At about sort of like 10 nodes or so, you start experiencing funny things where the nodes take really, really long times to boot. I was running Wireshark at the time that I ran this, or I ran in Azure, you can do network analysis on the firewall traffic. When you're running, when you're running that many unicast routes, it looks like what's happening is that you get packet drops on the cloud side, not on the host side. You start getting, I was getting PA0 driver crashes, of course, that were just cluster exits everywhere. Like I was SSH'd into about 10 nodes. And random nodes would randomly cluster exit at random times. It wasn't consistent. It was very funny to watch though. It did kind of freak out. And it looks like what I can tell, the boot times were exponential. So I set up in my script that the node number 1 would always boot first by basically saying that if your node number is 1, wait 2 minutes. So I always knew that node 1 would come up first, so I could get into one of them. But other nodes, it's like 3 nodes, it would take a little bit longer, and then 5 nodes would take a little bit longer, and then 10 nodes takes quite a while. I would be interested to run more of them just to test out to see what the cause is, but it's expensive. That's a screenshot of the first run that I did. And why I won't be doing it again. It's costing $300. And in the previous month, I ran a product which should enable, so multicast routing in the cloud doesn't work. So you are limited to unicast routing. I tried to run a product that theoretically enables multicast routing. That cost about $150 just to have running for an hour. I didn't even get to test it. I just started up and looked away and came back and saw my cost that graph. So no, I won't be running that. But theoretically possible. I'd be interested to hear if anyone tries it and has any success, because that could theoretically solve the problem with almost network flooding your cloud network with ARP requests, and may solve the packet loss problem. So maybe. So there's a few things that I want to improve. Let's test out multicast is one of them. I'm currently, the way that it works is just building one host of one VM. It could be interesting trying to run multiple VMs per host and then limiting the amount of hosts. 1, to save money, and 2, the cost of communication between the VMs on the same host. What we'd like to hope would be more stable, so you might get better results. The thing I mentioned about the 270 public IP addresses theoretically could be solved by running sort of like a file share in the cloud, like a server that has files on it, because currently what's happening is that the hosts are reaching out to Azure Blob Storage, which needs a public IP address to get to. So I could run an internal server and then save the money on public IP addresses. And instead of building a fresh VMS host from ISO to done, could probably do something with a master image QCal and changing node name and whatever else in that would probably cut down the amount of time that this takes to build. And that's probably, if you wanted something that spins up quickly, that would be the way to do it. Not the way that I went with, but yeah, that's something that I could do. Hopefully by now the demo is complete, but I don't think so. It's going to take longer than that. So I'll see if I can get to these recordings. Any questions? Anything you want to throw at me? Feel free. So it's basic. So you'll notice that the member status doesn't change. That is the problem that I ran into. The more nodes that you add, is that they never ever get to a point where they even like transition state. They just stay like that. They'll stay like. The 2 nodes, yes. 4 nodes, yes. 6 nodes, yes. 8 nodes, and 10 nodes, no. So I think that's where this is the one. Yeah, this is the one that I wasn't running. Get back to. Sorry. No, please. Yeah, sorry, I had to change, stop the recording and then pull it back up. So yeah, this goes on and all the nodes get added. But yeah, as I said, trying to traverse the cluster members, it just freaks out. So the recording is on here. Let's save there. That's probably the point where it starts needing to scroll. And I'm recording this on a 4K monitor and running PuTTY. It's like a 4K translation to an SSH terminal. It doesn't go very well. Close that. So what I'll need to do is open up my portal and we can see the resources that have been built. That's not the right one. So sorry about the yeah, so ready to event. Fantastic. Again, resource groups. This is the resource group that was created by Terraform, created with the VMS resource group. The only thing that existed in this resource group before we started was the storage account here. But man, this is gonna be like no room to read this. But you can see all the bits and pieces that are needed. Canyon Cloud provides bits and pieces that are necessary, some not. So there'll be the virtual machines, the disks, network interfaces needed for them, all with very creative names. But they get the message across and an SSH key, which will be used to SSH in the boxes. What I'm primarily concerned about though is I'm going to go to this node here and grab public IP addresses so I can SSH into them. Cool. I'm going to my trusty SSH client. I don't have any public IP addresses, so I change this every time. It's stupid that way. Cool. So we've got Linux host here. Inside of my custom script, I also have T to link. So let's see what it's up to now. Cool. Okay. LSPCI. Sure. Oh, that freaked out for a second. Is that what we want to see? What we got?
Let's see if we could do it.
No. So Azure is running Azure's running Hyper-V under the hood. So unless you guys want to support Hyper-V, science fell up for that. But the other thing too is I thought was interesting is that our Oracle Cloud is the only cloud provider that lets you upload QCOWs as standard images. VSI can provide a community image to Azure for that to be used. I mean, it wouldn't work obviously, but the ability to actually just upload a QCOW is unique in my experience.
And there is also a few with loaded ISO, and you just say it's a good file.
Yeah.
Even though there is no option for ISO, you can just pretend it's
Every other cloud provider that I've tried with, you can't just provide an image. Well, you have to say like here's an image ID, which is in like Azure's public repository or whatever. And that's something that I am interested to try to see because that is unique in my experience. So currently right now it's running through AutoGen. So the other thing about running expect instead of this, I'm not sure if I don't know if this will work with it should work with expect. Is your version consoling in can you version console on top of your version console? Like can you or would you mess up your expect script when you
we open the version console inside the expect.
Yeah, but if you then version console on top of that, will you?
I think it's not allowed because you can only have one.
Okay. So if I'm version console in right now, that will make it float, so I'm not going to do that. So because version console is taking over /dev/bts/0, and then if you try and let it in, it will let you in, but then bomb whatever's routing to it. At least in my experience. So that's why I'm gonna have to wait until it's done before I can show that it works. That's surprisingly fragile. Again, proof of concept. Please don't do. That's not a benefit to using expect versus just passing data. Let's go again, see if it's okay. Might be ready to go then. It also dumps all the scavenge out sometimes. I have no idea why. I've never figured that out. I don't know what character semicolon one is. Something. Yeah, I'm currently now just waiting, so I apologize. So it will be the presentation going on. Any questions? Any concerns?
You can potato minus F. I can tell myself if I feel wrong.
I could do that. It will also dynamically update this when it's done. So we can do that there. What I am doing is all in my private Git repository. If anyone wants to have it, they can have it. Yes, I want it, they can have it. I just built it for fun. As I said at the start, I've built Azure, AWS, GCP, and OCI. I think Azure and OCI, the two ones I have the most success with. AWS doesn't do nested virtualization unless you do a bare metal instance. A bare metal instance will cost you about $50,000 a year. If you've got $50,000 a year, you're nuts. I don't. So GTP is a similar situation as well. No nested virtualization without running bare metal instance. So, but luckily Hyper-V and CDN KVM does like nested virtualization too, but other cloud providers just don't provide it, and I don't know why. It's very strange. But OCI, as I said before, is seemingly the only one that can run it there, like I said, I'm just running QCal, so you don't have two layers of nested virtualization, you only have one. So now I'm gonna watch this through it. Sorry.
What are we allocated in terms of storage for the VMS system?
So storage, I am using, so I don't know the exact IOPS numbers because Azure abstracts that away from you, but I'm using the premium local redundant storage within Azure. There's 100 gig for the host and 50 gig for the VM. Those numbers are, you know,
That size 240.
But
240.
Yeah. Yeah.
But if you believe the VMS gives, well, that's just general storage, right? So it's kind of like if you want to store your crown jewel data on that.
Yeah. So I haven't tried using, say, like blob storage to connect to the host. I think it is possible.
That's kind of where I.
Yeah. So I've kind of started going down the rabbit hole of mapping cloud storage. Again, proof of concept with the trust. Cloud storage to the VMs. So if you've got two VMs that are geo-redundant and you map cloud storage to those VMs and then pass those disks to the host and have these sort of emulate SAM wrap, maybe.
Version 1 is shareable across regions, version 2
Mm.
is not.
Theoretically possible. Yes, right now, but yes, this is gone. Haven't really, didn't really think of that kind of use case.
Like you say, it's just proof of concept.
Yeah. The kinds of scenarios that I'm picturing that this could be useful is sort of in a development pipeline. So obviously this takes ages, not this, but using a master QCal image, you could theoretically bring this into a Git pipeline. And on a code deploy, part of your pipeline is to build a VMS image from a QCal in cloud storage, upload your code, run code, do your testing, delete node. And if you're running that node on Spot, that will cost you fractions of a cent per hour. That is the kind of thing that I'm thinking of. The other thing I'm thinking of too is, I don't know about anybody else in this room, but I was learning VMS recently and still am. Trying to find a development environment which not only people don't get mad at when I break, that hasn't been scarred by 20 years of different developers going and making their changes to it and not cleaning up after themselves. If you're trying to teach someone VMS, and you've tricked them into doing that, no, that's scary. And you want to provide a clean environment that you can destroy and repeat as the same instance over and over again. That's the kind of use case that I think that this might have. I know that, when I was learning, trying to make changes, potentially breaking changes to a development system, as typically people get pretty upset when you break their dev systems. So a sandbox environment is kind of the use case that I'm thinking. Okay, it's fine. Kind of concerned now because if something breaks during the script and doesn't kill it, doesn't exit zero, then it just times out. You can go for it, like hang around for an hour. So yeah. It's still done. That's okay. The other thing as well with Azure is that I don't have to do any of the, as I've mentioned before, Azure does DHCP on all network interfaces, so you don't need to do any manual IP addressing, which is super handy because trying to maintain that would be a pain. Trying to build dynamically and then having to statically set addresses. So don't have to do that at all. I will talk about the things that Raphael and the guys at BSI helped me out with. I think it's been mentioned a couple of times now, DefNet based wall breaks. So if you're not encapsulating DefNet at all, pending 2 characters to your MAC address, cloud network devices do not like that. They will drop all your traffic. So definitely swore I had that on because I was just clicking yes to every install option because I didn't really care. And that was great stuff. The other one was, because I was defining the machine with an XML, and I had a MAC address within my XML as kind of a dummy placeholder address. The way that KVM will work is that it will get the MAC address that you've set in the XML and transplant it onto the Ethernet adapter that you're trying to use as a pass-through. Which cloud network devices also do not like, because they don't know what that MAC address is. They're expecting traffic from the MAC that they assigned, and they're getting traffic from something else, drops all the traffic. You need to do, I think, the method that VSI might be using it might have changed, but the way I was using it was it said, just get the MAC address from a Linux file where it's stored and transplant it into the XML. And then after that, pretty much worked on the tree. Didn't really have any problems beyond that, apart from the more nodes you had, more problems you have, seemingly.
Is it tail minus F? Is that file?
Probably waiting.
Yeah. Nice return.
There's one more step I remember now why it's doing that. I don't know if you guys have come across this problem, but when you set the UDP port in sysgen, the UDP port is set to 0. You guys come across that? Every time.
It allows everything.
Sorry.
It allows all ports.
Really?
Yeah.
Oh, there you go. Because when I'm seeing the documentation, in sysgen, the NISCS UDP port is set to 491.2, whatever the default is. And then every time I look, it's set to 0. So why is it set to 0? Then if I'm saying, well, okay.
We also just picking the default.
Oh, I see. Yeah, that's what I was doing. And then I have a little bit of the script at the bottom which changes the UDP port and then auto gens again, and it's set to 0.
Yeah.
Wow. Well, there you go. That's something new. You have NISCS console UDP port set to 0, then allows any port for cross-country traffic. No, I'm not setting it to 0. I'm setting it to what? Why did that get wrong? Yeah, sorry.
That part
It's an interrogation. I was scratching my head trying to figure out why, because I was setting, because the firewall had because Azure doesn't inherently allow all same subnet traffic, so you need to set the firewall rule, which is a little bit why Azure has a little bit more resources to create compared to other cloud providers. But I was trying to limit it down to 4 by not allowing any. And then I was finding it was set to 0. I didn't know what that meant. So then I just went and set the allow to just any port, because I mean, who cares? But like, for someone that's not doing this for fun, then that may have been a problem. But there you go. Okay. This is going to take slightly longer because it auto gens again unnecessarily trying to set the UDP port manually.
Anything that it first track,
Sorry.
so anything that default first track.
Yeah, you just echo a return. Handled. Yeah, you can, that's one of the benefits, I guess, of just passing carrot. You just treat it like someone's carrot returning that. I think now it is done. I'm also doing it as sudo. Whoops. Oh, wait. So we're going here.
I've got a question. Can you
Sure.
talk a little bit more about when does the Terraform script itself finish and when does your bash script actually start? So when, how far does the Terraform go and what is the start place each one?
That depends on what you set up for me. I've actually set up linear dependencies. So Terraform kind of wants to do everything all at once, which it can't really do. So there's actually a chain of dependencies. Terraform has that's thing called depends underscore on, and then you define other resources. So it has to wait for that to be finished before it moves on to the next one. So the first thing that happens is I let a bunch of stuff happen at the front, which isn't really necessary. So the sorry, isn't dependent in the chain. So the storage blob, the file uploads, the networking. But the main thing is that the VMs can't start until everything before it is done. So all the other resources have to be done first, then the VM, and then the script. So you can't have it. You know, Terraform wants to go and just do everything all in one go, which yeah. So you do, but you can control that. So
So the Terraform calls it create. No, you're talking about the VM, the Azure VM, not the Oracle VM.
oh, sorry, the shell.
Yeah, so basically the Terraform creates the Azure VM.
Yep.
Then it will probably set it to boot. And
Yep.
I think then you talk about the place only the package is needed for your KVM.
Yeah.
So
Okay.
which part, where's the?
Terraform doesn't report that the host is finished until the host is running, is booted and running. So that's only when it passes that as complete. So what's happening here? Something there. Yeah. So the only Terraform doesn't get a success in the same way that Terraform isn't reporting a success until this script is done here. So if I want something to happen after this script creation, it would wait until it got an exit 0 from this custom script extension. Other cloud providers do it differently though, because other cloud providers do cloud in it, like you should, which makes way more sense. So in that case, Terraform is not aware of where your script is up to, but with Azure is aware of where the script is up to.
Right.
Woo! Done, theoretically. Let's see if it's actually done. That's still good. By the way, I'll grab the other. You can, if you've got static public IP addresses, you don't need to do this stuff. It's just because I don't have any. Yeah, so the script is actually, it has a sleep after the autogen, and then it runs, because it has to cat the, serial file before it starts making strings to it, so it has a kill on that cat process, and that's when it reports as done. It's not actually waiting for the VM. It has no idea about the VMS VM. But it is starting its final boot now, which is taking a seriously long time. These are running on Spot at the moment, so I had a lot better time running on the non-Spot variants because Spot is like kneecapped in terms of I/O. So the 256 nodes work quicker in terms of this kind of stuff, where it's boot times. Any other questions?
One other thing, do you know how Terraform actually does in the background? Do they have the implementation for each cloud provider's command line interface?
Yeah, and what sort of stuff? Each implementation is different. Oracle's implementation, actually, I shouldn't say that. Oracle's implementation is the most interesting. I say so. Oracle actually do their own. So Oracle's doing Terraform in the backend. So like when you're passing Oracle like shell commands, it's doing Terraform. You can download whenever you're creating Oracle resources, you can download them as Terraform because it knows it as Terraform, which I thought was pretty cool. what I think is less cool is that the way they have done Terraform is they have their own provider. So Terraform is a provider of Terraform, which is kind of a weird way to say it. But Terraform does like Azure, AWS, GCP. They write the code. They work with the cloud providers. Oracle will do it a different way where they don't really interface with Terraform at all. They do it all themselves. But the really fundamentally is just doing HTTP requests, and it translates code into HTTP requests, not necessarily like shell commands, but HTTP requests that those cloud providers understand. Which is why you can't just pick up Terraform, like my Terraform, you can't pick it up and move it to OCI. You have to go and write new code, which I went and did because I'm crazy.
Yeah, I experienced when you do the HTTP request, but within a lot of those, like, directly.
Yeah.
It ends up in a Python, internal Python script in the guy, which then gets converted to something else, and I guess it's something else in there.
Gotcha. Awesome. Cool. Hopefully the other node is built as well. No, it hasn't yet. Okay. Yeah, it's still going. Or it hasn't joined the cluster at all, which would be hilarious because I've done this about 1 billion times. Yeah, it hasn't. Fantastic. Oh no. I don't even want to know why that hasn't worked. Oh dear. I mean, I can run a reboot and see what happens, but see what happens. That's tragic. I promise it does work. And it does cost the transitions and everything. Oh no. It's like I probably look away, see if I've done something in this. So, yes, this is the bash script that's running in the background with a lot of comments on what questions being asked, so I know what the hell's going on. Yeah, good. Anyway, there you go. The gods have not blessed me with live animation. Oh no. They're in the same zone too, so you're going to get across regional noise. I'm in the same zone, same subnet, same dangerously unencrypted, well, unencrypted cluster traffic. Oh no. Disaster. Anyway, if this doesn't build right now, then I've run out of time. So you just have to believe me, unfortunately.
We did.
I do have a video, I have a video, but I had to video that takes screenshots because I need this without them. The other interesting thing too was, I think out of all cloud providers, Azure requires the most amount of, I guess, what I'd call like faff around the nodes. So you need, you need, is that address? I'm just confused as to how, because it actually does the addresses somewhat sequentially in Azure, which is really handy too. Like it'll say like, it usually works out to be that your first address gets the first available address, and the second address gets the second available address, and so on and so forth. So when you're doing the unicast, so you don't need to do 512, you could just do however many nodes you want to. But yeah, Azure requires most around, like, in terms of infrastructure around it, so it needs the network security groups, the network security group associations to associate different devices to those things, where, like, I think in Oracle, it's just like, here's a machine, here's a firewall. It's on the same subnet, it talks to firewall. You don't need to go and manually assign everything to the resources. 204. Absolutely classic. Wow.
One more.
No. The other thing I was thinking as well, which might end up becoming another terrain project is, using the OCI sort of as a concept of burstable resources. What it could do as well theoretically is set up something called a scale set, which has certain parameters assigned to it, which can not only, obviously VMS, you can't dynamically scale memory and CPU live, but you can set up resources or like parameters that if you reach a certain threshold of I think quite literally anything, I don't think it really matters. Just as long as our thresholds hit, it starts adding more nodes to a cluster, which obviously you run into a problem once you hit a certain amount. But if you're running 2 nodes and those 2 nodes are getting hammered with whatever, you can scale horizontally automatically and scale back down as well. So that might end up being something else that I end up working with. Taking heaps to boot, oh my god. I just did not do a screen. Fantastic. Oh no. So yeah, didn't try to cluster. Oh well, tried if I tried. Dear me. Anyway, that is all. I apologize. It probably doesn't work.